Hello guys, so right now I will gonna go to another programming language, which is Python programming, and I will gonna teach you right now the topic about recursion. Well, recursion, it is from the word recur. That means to say it is occurring once again. In when I search into Google, the definition of recursive or recursion is it comes from the Latin word recurrere. That means to say that to run or hasten back. So that means to say that he will go back or return or revert or recurs such a thing. So recursion is just recursive function is just calling a function in itself only. So that means to say that when you call the function, it will gonna go to the function and then run that function, and then since it is calling itself, it will always recurring or go back to the function to run the function once again until there is a statement that will end up or terminate the running of the function. So inside of that body of the recursive function is it has such like a case statement or a switch statement or if and else statement. So if the criteria or if the expression is reached to its final equivalence, then that's the time that it will stop or terminate the recursive function. So let's try to create an example for that. So we will gonna create a body of recursive function inside in a Python programming language. So it's, I think it's new to you, but this will gonna be easy to comprehend, since Python programming is just much simpler compared to other languages. So if you want to learn programming language, it's much better to learn some easiest language, and that's the language is the Python. So let's try to create a function which is def, meaning to say that you're defining something, which is defining a function, and then you're defining a function which is named countdown. So this time we're gonna create a countdown function. So you are declaring that Python, please create a function which is being defined as a countdown function, and inside of that is its parameter. So here we're gonna make a statement that if this statement or expression is finally reached in its final peak or final portion, then it will gonna terminate. So how could we able to create is we're gonna use the switch statement. So switch, and then like that switch. It's better to use the if and else statement because we have not discussed the topic about the switch statement. So this if and else statement is much easier. So if n is equal to 0, then we're gonna say that it will return to its termination point. So this one terminates the function, the recursive call or recursive function, when it is it meets this one, n, which is n is equal to 0. And then else we're gonna create else, then that else if it's not equal to 0, then we must return. And this return value is just like saying to the computer, please compute this one, and then please work this one for me and compute this one for me and save this one for me, because I will gonna call this one some other time. So in this return value, we will gonna use this variable, which is n, which we are using a countdown. So we're gonna create this one as countdown, which is countdown, which is a function of n minus 1. So that's how it works. So countdown n minus 1, this means to say that when we try to use the n here, we're gonna use this one, we're gonna subtract the value of n to 1. So that means to say that it will gonna decrease to its lowest number or value, which is could be 0. And if it's 0, then we're gonna return to 0. And then here, since we are trying to get the return value for this one, and also we will gonna terminate this one, so we're gonna use the print function, which it will try to print out the value of n. So as you can see in here, countdown n minus 1 is inside of this one, of this function that we define. And then if this function is being called outside, then it will gonna run, and then we will gonna create the value of n, which is n is equal to, it's 10. So since the value of n is already inside the variable n, so this parameter here will go to this one. So let's try to create this as number, like that, and then we're gonna use this as a number so that you will not be able to confused. You will not confuse with this one. So countdown num will be called this one. We'll call this function that we define, right? And this inside of this is equal to 10. So this 10 here, we're gonna go here, and then it will gonna print as we have said in this in this code. We said that print n. So therefore, it will gonna print the number value of 10. And after printing that number, it will gonna try to check if this statement or expression meets the value that we try to check. So as we all know, it's 10 is equal to 10. So this means that this won't run. However, since this is an else statement, so therefore the countdown n minus 1 would be executed. And then when it is being executed, countdown n minus 1 will be computed by the compiler, and then it will gonna say that countdown will become like this. Countdown, sorry, hashtag, sorry, countdown will become 10 minus 1. So this will become 10 minus 1, and we all know that 10 minus 1 is equal to 9, right? So this one, the return value for this would be equal to 9. And then this, since it's equal to 9, so we all know that it says here that there is a function that is in outside of this value, right? So it's gonna be like this, countdown. So the countdown function, this countdown function will gonna be calling this function in itself, right? Because it is inside of this function that we define. So we are calling this one countdown. So it will gonna execute this function again. They call out this function again, and this will be executed again, and then this will become 10. It was 10 previously, and now it will gonna be a 9 value. So since it's a 9, so it will gonna check if this state expression is matches with this value. Since n is not equal to 9, so therefore it does not meet its equivalence. So you are gonna proceed to this else statement here, and we all know that else, since it's much greater than 0, therefore this will gonna run or be executed. So this, as this being executed, countdown 9 minus 1 again, and then it will gonna be it will be come 10 already, which is 9 already, and this equal to 8, and then so on and so forth. It will gonna call again this function, and then after calling that function, it will gonna print until such time that n will be equal to 1. And then after that, if n is equal to 1 already, then therefore it will terminate. This one is a termination of recursion, that it will terminate. So it will gonna return, it will gonna end up, because there's no recursive call for this one here. This one is a recursive call because it calls out the countdown function. So after that, it will gonna end up, and then the last one, right? We all know that 0, when n is equal to 0 rather, it will gonna be terminated. As we have said that if n is equal to 0, then it will be terminated, because this does not mean its value. And this one also, this one is the one who meets the value. So we said that please terminate it, or we just simply say quit or exit. This one return here, that means to say that terminate or exit this code. And then we all know that before it is being executed, println says that you are trying to get the value of the return value, which is here the last one is 0, right? Because n minus 1 becomes 0. So that means to say that you are calling the value the function countdown to its parameter, which is 0, and then it will gonna print this value of n, which is already 0, and then after that it meets this one. So since it meets the value of n, so we said that if that's the case, then we will gonna terminate this code. So this one, return value, terminates the code. So now let's try to check if this is really a correct code, if there are no errors for this. So let's try to run this one, and then as you can see in here, it says that 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and we have run the code to its countdown function. So another idea for recursive, it's just like for loop. We know that there you have maybe you have used for loop already in using a countdown, and also a stopwatch. Maybe you use that. You can still also use recursive function in doing that one. So it has the same approach with the for loop function, which you can be able to create countdown timer. And but also, however, there is much usable purposes for this recursive function, and the wonderful example for that is the factorial. So this factorial is is very much useful. It is preferable compared to for loop because it's much easier to use. So let's try to have an example for this. So we were gonna create a file which is Python. Create a new file py, and then we're gonna use factorial for this. Okay, so we're gonna make some example for that in this so in this sketch or whiteboard, so that you could be able to comprehend easily how this factorial works. Okay, so let's try to concentrate on that what we call this recursive function, factorial using recursive function. So this is a mathematical concept, so therefore it is using a factorial. So we all know that factorial is just like this, n factorial is equal to n times that times 2 times 1, right? So that's the scenario of that factorial, right? So it's the same also with this one. 1 times 2 times 3 times 4 times 5 dot and times, and so it's just like the same with that kind of approach. So that is an n factorial. So how could we be able to use recursive function using a factorial? So here right now we're gonna discuss to you that example. So we all know that this one here 5, it is being decreased by 4, and then 4 become 3 and become 2 and then become 1. So right, so as you can see in Fibonacci sequence, you know the Fibonacci sequence, right? That if 5 minus 4 is equal to 1, 4 minus 3 is equal to 1. So 2 minus 3 is equal to 1, and 1 times 2 is equal to 1. So factorial means it is divisible by 1. It could be subtracted by 1. So it's like this one. Recursive function could be like this one. So n minus 1, right? That is a factorial when n is equal to 1, right? So n minus 1 equals to 1 minus 1, right? So it will become to 0. So 1 factorial is equal to 1 minus 1 equals to 1 times 1 rather. Sorry, 1 times 1 is equal to 1, right? So that is 1 factorial. But how about 5 factorial? So 5 factorial is equivalent for that is just like this. 5 times the factorial of 5 minus 1, right? Because 5 minus 1 here is 4, and 5 and then that's there is a exclamation point right there, right? So this one is 1 times 1 minus 0 factorial, right? So this one becomes 1 minus 1 0, or rather. So we all know that 1 times 1 minus 1 factorial, since it is a factorial, 0 factorial. What is the 0 factorial? We all know that it's 1. So this 0 factorial will become 1, so multiplied by 1, so that is equal to still 1. And then this one is 5 minus 1 factorial, so this will become 5 times 4 factorial, right? So until it meets to the last one, which is on 0, right? So that's how factorial works. And we're gonna erase this one. Erase the value. discussed. So how could we be able to comprehend how a pseudocode for this? So let's create an example for this. So let's do this one. So n factorial. So this is a pseudocode so that we can be able to understand how factorial works in this function, in this recursive function. So when n is equal to 1, remember, we have to create a base statement for this, which is the 1 value, and then 1, it will be 1 if for example or for let's make for n is equal to 0 or n is equal to 1. So there will be as we have computed earlier, that when the n is equal to 1, automatically it becomes 1, right? It becomes the answer for that is always 1. So when that is the answer, when n is equal to 1, then therefore this will be the return value. Okay. However, if it's not yet equal to 1, we will gonna use the formula or the equation that we have used a while ago. So what's the equation? This one is the equation: n times n minus 1 factorial if or for n is greater than or equal to 2. So in this example for this one, remember that if this is 0, and this is 1 and this is 2, so the value for this 0, 1 here is equal to 1, right? When n is equal to 10, like that. When n is greater than 2, which is 3, 4, 5, 6, 7, and so on and so forth, then it will be equal to n times n minus 1 and factorial. So this equation will solve this the problem how to use factorial in recursive function. And why? So let's take a look again. Remember what have we computed a while ago, calculated a while ago. For example, okay, so let's try to check if this is correct. So for example, let's try to create if n is equal to 3. So let's check if n is equal to 3. So since n is equal to 3, so if n is equal to 3, we have to check of if where does it meet in these two options. Okay, so these are the choices, right? If it meets or not. Since it does not meet here because n is not equal to 1, right? Or n is not equal to 1 because it is 3, so therefore it will pass. However, he would go here and he will gonna check this one, and as you can see in here, n is greater than equal to 2, right? So n is greater than equal to 2, so this will gonna be the one that is correct. So this is n is equal to 3, so therefore this is 3, right? So 3 times 3 minus 1 will become 3. 3 times 2 minus 3 minus 1 is equal to 2, and then factorial. What is the factorial of 2? It is 3 times 2 times 1. So what is the answer for this one? This is 6. So the factorial for that one is 6. So we get it, right? So this is the correct formula or equation for factorial. However, how could we be able to use this one in Python programming? So here we are gonna discuss to you about the solution for that. But before that, we're gonna go to this code so that we could be able to make a code for that, so that you could be able to understand easily how does this work. Okay, so let's create a function or define a function named factorial, and then we're gonna use n again. So, and then since we are declaring a function, we have to put a colon there outside the function. So so inside of this function we were gonna say this here, that if, okay, if and only if n is equal to 0, we're gonna say that return value of 1, okay, and if we're gonna use this one, n is equal to 1, then we're gonna return again 1. We can also use this with an or n is like that. It's the same, it has the same result with this one, so it could be easier. Okay, so that's the how it works. So now what we're gonna do now will be we're gonna put else statement here, that if it is greater than or equal to 2, since we have used this one here, n is greater than or equal to 2, we're gonna use this one. Okay, so n is greater than, if n is greater than equal to 2, okay, then we can use else if here. Okay, else if, and else if means there is another expression for that, but it is different from else, or else you could be able to put else only with that expression. It means to say it's beyond those expressions, meaning it is negative. So when it's negative, then it will not work, it will not run. So it depends upon you if you were gonna put else or not. So for me, I would not gonna use else if for that. so we can also use else only, because it is understandable that it is greater than 1, right? And there is no negative value for factorial, right? So we're gonna return because return is meaning that, hey compiler, please do this work for me, without knowing what are you doing there. Just do it, and without knowing, without seeing, because it's inside of the compiler only. You can only be able to know the value of that if you want to see it, but you can only see it if you want to print. If you want to print out what is the return value for that. So return value is you are returning something to the compiler that please work this out for me, sum or compute this one, and then return that value here there. And now we're gonna use that one someday or somehow or some other time. So here we will gonna use the multiplication or the equation that we have created a while ago. So we all know the equation is n times factorial. It is the time that we're gonna use the recursive function. So why? Because this will gonna be useful to call out the function that we have defined until such time it meets the limit. So the limit we all know is n is equal to 1 or 0, right? So this one we're gonna subtract the value of n until such time it decreases to its limit minimum number or value. So what is the result for this? So as we all know, n times factorial n minus 1, right? is equal to n times n minus 1 factorial. So if the value of n is, for example, we're gonna create the value of n. Let's just try to put an example for this. N is equal to 3. So you're declaring the variable num to have a value of 3, right? So this integer value would be inside of this function. But how could we able to do that? So this is the time that we have to use the print function, that the factorial of this one, which is the value of number, is like this. I'm sorry for the dogs, guys. It's in my neighborhood. So here the factorial will be, we are calling this factorial now. So here, this factorial of num is factorial num. We are calling out the factorial num, and then after we are calling out, we are printing the return value for this. Okay, it is one time only, because it's outside of the function, right? It's not the same with this one that it is inside of this function, so it will gonna be printing out the value of that one. So this one in here, you are printing the result, the final return value of this function that we have created. So we have defined the function in factorial, and then it will gonna make a factorial value for this number 3. So what is the factorial for this one? So the formula again is 1, and then it will gonna return the value of all those factorial. So I will gonna discuss to you later on how does it work. Okay, so let's try to run this code, and as you can see in here, the factorial of 3 is 6. So as we have made in this example, this one is, the result is 6, right? So it's the correct answer for that one. So how did it work? Why it has a result that is something like this, that is so the same with what we have answered in our handwritten computation calculation. So here it goes, how it goes. So let's go back here, and then we're gonna simplify that. We're gonna simplify it. I'm just looking for my, where did I put it? Oh, it's here. Okay, so let's gonna erase this one here. Okay. Okay, erase. This one, we're gonna erase this one here. And then, so here it goes, how it works. So when we use the factorial, so we have a function, right, of factorial, right? So we are calling this factorial in this value of 3, right? So since it is the value of, has a value of 3, so this one is the first call, this one is the first call. Sorry for that voice. This one is the first call, which is with 3, right? With 3. After we're calling that one, and we will go here to this code here. So this here, so I'm gonna say something like this: factorial 3, since it is the first one, right? When it is 3, so n is 3, then that means to say that this one will gonna be not much in this value 3, which is n is equal to 3, right? So it will go here, because it matches. And then when it is matches, it says here that n should be multiplied by the factorial n minus 1. So this one factorial will gonna be calling out again this one factorial here, And then before it is being calling out, it asks a return value which is 3 minus 1 times 3, right? So this one gonna be like 3 times 3 minus 1, which is equal to 3. We're gonna return, as we have said again a while ago, a value, or this one is gonna be returned 3 2, which is like that. So this one will gonna be 2. So n will become what? N will gonna be equal to 2 already, because n minus 1 is 2. So therefore, this factorial will gonna be like this. Factorial, you will become already a 2, already a number 2 value. So this we're gonna call this function again that we have defined, but it's already, it will become 2 already. So since it is 2, it will gonna go here, and then we're gonna transfer this one here. Then this will be, since it is factorial 3, in the second call, remember that in the second call you have factorial of 2, right? Factorial of 2. So that is the factorial of 2. So since it is a factorial of 2, we all know that this one is the second call, right? Second call with 2. So here it goes like this. Mathematically formulating, we have this first a constant 3. Remember that one, the first value. Okay, the first value that we are trying to factorize. So 3. So this one will be constant. Okay, remember that one, because this will help us to comprehend how does it work. So it's like this one. So 3 factorial, right? Constant function of 3. So this 3 we're gonna be put inside this one. So 3 factorial, 3 times 2 factorial goes like this. 3 times 2 factorial. Do you get it? So this one is 3 factorial, right? This one is 3 factorial. So it is not yet being factorized. Okay, so this one we're gonna be 3 times factorial 2, which means to say that it is this 1. Okay, and after that, in this third call with 1 already, because it is already 1, so we're gonna erase this. Sorry. This one is undo. So again, we're gonna go to here. 3 factorial times 2, which is it becomes again another constant. So factorial of 1. So every time the recursive function decreases, the factorial number parameter is decreases as well. So this one, 3 to 1, it's in the third call. So here it's 2, right? So this will become 1 again. This will become 1. And then so on so forth. Factorial of 1 become factorial. This one we're gonna be factorial of 1. And then until it's such time, the time comes that it meets this expression, it becomes 1. So the expression here is, if n is equal to 1, then return value of 1. So it will not continue here. This will not work already. This will not gonna run. Okay, because this one is met. it matches the value of 1. So that's the time that it is equal to 1. So the factorial of 1, we all know that factorial of 1 is 1, and then factorial of 0 is 0. So that means to say that it is now ended. So the program stops working. So let's check this one out. Okay, let's go here to the whiteboard. So here 3 factorial 3 times factorial 2, 3 times 2 factorial 1. So this means that we have to factorize this one. So let's check how does it work. So this one, return here, return from third call, which is n is equal to 1, right? So this one here, we're gonna have a value of 3 times 2 times 1. Okay, because we are returning the value of 1, which is equal to 1. So this one is gonna be the value. So as we all know, 2 times 1 is equal to 2, right? So 3 is equal to 2. 3 times 2. So it returns the value of second call. So this one is the second call, right? So it's like that. It's just the same with that approach that we have created this one. And then after that, it will gonna, if you multiply this one, since 2 times 1 is equal to, so let's erase this one so that you will not get confused. So 2 times 1 is equal to 2, right? So this is 2. So 3 times 2 as the factorial, the first call, is 6. So this one will gonna be and has an answer of value 6. So return the value of first call in our function. So this is the answer. So the first approach of factorial is it will gonna execute the return value. So this one, 3 factorial equals to 3 times 3 minus 1, right? And then after that, it will run again to the I will execute I call the function, and then until it will become 3 times 2, which is 2 times equal to 2 times 2 minus 1. So it will become the factorial will become 1. So therefore the factorial will become will be matched to the first statement, which is if n is equal to 1, then therefore the return value is equal to 1. So that's the time that it will gonna be multiplied. So let's go back to Visual Studio Code here. So this portion here, it goes like this. When we call out the factorial n is equal to 3, so this will become 3 again, being multiplied by 1, so it will become 2. So 3 times 2 factorial is equal to 6, right? And then before that, it has to factorize the value of n. So after that, when n is equal to 2, so this one will become 2, and then it does not meet this expression here, so we were gonna proceed here. So 2 times n minus 1, which is 2 minus 1, is equal to 1. So 2 times 1 is equal to 2. Therefore, answer for that is 2, right? So it is returned as 2. And then here n is already 1, so we wanna call out n is equal to 1. So since it is equal to 1, so therefore it will return the value of 1. So all in all, if we will gonna think of it as a factorial, it's just like saying that simply speaking, this is how it works. Just gonna erase this one. Erase everything. So here we're gonna use this one. The first call, 3 times 3 minus 1 equals 3 times 2, right? So that is a 2 factorial. And then this one, 2 factorial here, you're gonna factorize this one again. So there is a remainder 3, right? And then you have to get the factorial for this one. So the factorial for this one is 2 times 2 minus 1, right? Factorial. And then the answer for that is 2, right? So this 3 will become 2. 3 is multiplied by 2. And then after that, it's 1, right? So this one we're gonna go to the function, which is 2. It is already that is 2 factorial and 1, right? So this one is bring here, and then 1 is again, okay, 1 is called out, and then if the value of n is equal to 1, so it will become returned to 0 or 1, right? It will to 1 rather. So if you multiply this one 3 times 2 here, what is the answer for that? It is 6, right? And why do we have to multiply this one? It's because here how the phenomenon of this function. So remember, as we have created, right? We have created, right? The value is like this: 3 times or n times n minus 1, right? Or 3 times n minus 1, n minus 1, right? So here there is a multiplication, right? Right. So that means to say that since it has a multiplication, so you are returning what you have returned, right, is 3 in the first one. 3 times 3 minus 1 equals say times 2 factorial, right? So this multiplication here is the one that is being used in here. Okay, and this factorial here sorry for my voice, 2 times 1, right? It is 2 times 1, but we all know that it's not important because we do not need to need recursion already, so it becomes 2. So this here, this 3 times multiplied by 2 here will be this one. So that's why it was being multiplied. So after returning the value of each of the call, it will gonna have a product output for those following function factorials. So it will gonna have a multiplication operation with this. As it's the same with the 4 factorial. So it's the same approach. So 4 factorial, we're gonna have a 4, and then multiplied by 3, and then multiplied again by 2, and then that's the answer for 4 factorial. So it is 24. So this 24 we're gonna be the answer for that one. We do not need 1 here because 1 is 24 times 1 is equal to 1 already, and there's no we just only need the execution, the determination of the code. So this is the only one that is being computed as a product of the final product, or final result for that one, for that factorial, because we have used, as we have we remember, we have used this multiplication 3 times 2 factorial. So every time the function is running, it will gonna save this one multiplication, and after saving those saving those operation, it will gonna multiply the result for that. Okay, I hope you understand what I am trying to say for this, so that you could be able to use that one. Okay, so that's how the phenomenon of Python works, or the programming language works. So we have created that example. So that is the answer. The factorial of 4 is 24, and so on and so forth. So I hope you get the point of this equation here. Okay, so this factorial n 3 times factorial of 2 minus 1 n minus 1, it will gonna multiply the first n, and then multiplied by that one. Okay, so that is it, guys. So I hope you have learned something new with this tutorial, and it will help you, okay, towards your journey to be a coder. So that's all, and thank you, and goodbye.